Hey, boys and girls, welcome back to another edition of Crush Lusher Television. All right, hope everyone had a happy Easter and is safe and healthy. We're going to continue pushing on to our AP Calculus exam, knocking out a 5 by doing more of these free response questions. So here you go. So here's the problem. It's at the end of the PDF, and I want you to try the best you can right now. So try the whole thing right now before you look at any of my work or any of what I do, okay? So pause the video, time yourself. You can take 15 minutes if you want, because generally that's how long it takes. See how long you can do it in 15 minutes, and then come back, okay? Ready, set, go. All right, cool. So first we read it. Rocket A has positive velocity after being launched upward at initial height of 0. So it's a rocket, just bam, going up, okay? At time t equals 0. The velocity of the rocket is recorded in selected values of t over the interval 0 is less than or equal to t is less than or equal to 80 seconds. So between 0 and 80 seconds, as shown in the table above. Okay, so essentially the rocket is launched, and then at all these second intervals, we figure out how fast it's going. All right, so it's still going up after all these 80 seconds. So all these are positive velocity. Okay, so the rocket's still going up this entire time. A, find the average acceleration of rocket A over time interval 0 is less than or equal to t is less than 80 seconds. Indicate units of measure. Okay, so we have to find the average acceleration and units of measure. So average, that's like the average rate of change, because we have position, velocity, and acceleration. Okay, so looking at what we have, so I wrote down a little chart. Thank you very much. So average acceleration, we know PVA, we're at velocity, we need acceleration. So average acceleration is going to be the rate of change of this. So that's just the slope. So I'm going to create my chart. So T is always, this is the X, this is the Y, and then V of T. So between 0 and 80, that's what we're talking about. And so we have V of T is 5. So we're going 5 feet per second at 0, and then 80 is 49. Bam. And so this is going to be 44, and this is going to be 80. So we're going 44 feet per second over 80 seconds. So that the average acceleration, this is A sub AV, or A sub AVG if you want, equals 44 over 80. Now units are important, because this right here is feet per second, and then time is in seconds, so it's feet per second squared, because this is going to be feet, this is going to be feet per second, this is going to be feet per second squared. And if you don't have this part, it's going to be wrong. Now you can simplify this if you want to, but you don't have to, since it's free response. This is an acceptable answer and you get it right. What if we divide this by 2, cut it in half? We can cut that in half also. So I think that would be the final answer if you want. Okay. B. All right, let's do B. All right, nice. Doing good. All right, so what's B look like? Using correct units, explain the meaning of the integral between 10 of 70 of v of t dt in terms of the rocket's flight. Okay, so we need an explanation. We gotta know what the hell is going on. And then use a midpoint Riemann sum of 3 subintervals of equal length to approximate the integral between 10 and 70 of v of t dt. Okay, so let's see what we got. Part B. So the integral between 10 and 70 of v of t dt is, so that would mean the integral. So if you're at velocity, the integral would mean the position. So that would mean the displacement, or you can say distance, and this is all positive, because usually distance is the absolute value, but it's not. Ignore that right now. The displacement of the rocket in feet from 10 seconds to 70 seconds. Cool. So that's what it means. So the total displacement of the rocket, so that means how many feet it traveled from 10 seconds to 70 seconds. That's what this integral means. Now we have to find the midpoint Riemann sum. So that would be, so between 10 and 70. So if you don't understand how to do this, always just draw it out. But we know that we can do this and figure out. So this is the base and this is the height. So this is the base, this is the height. This is the base, this is the height, this is the base, this is the height. So that would mean that the integral between 10 and 70 of v of t dt is approximately, because this is just an estimate. We don't know exactly how many feet. We just know these velocity measurements. So the first rectangle is going to be 20 is the base and 22 is the height. So 20 times 22 plus is 20 times 35 plus 550 to 70 is 20, and this is 44, I think. Did I write that down right? Let's double check. Sometimes my handwriting is jacked up. 44. Yeah, cool. All right. So this is 44. So it's 20 times 44. And you can leave it like this if you want and just put this as feet. So you don't really have to simplify this. You can leave this, you get full credit. But I think the answer is 2020 feet. Weird how that works out. 2020. All right, now part C. Almost done. All right, part C is usually the most difficult. So let's bear down and figure out what's going on. Because if you get part C right on the AP, you know you have a huge advantage over everybody else. All right, rocket B. All right, so this is rocket A, is this stuff. Rocket B, all right, this is a different rocket. It's launched upward with acceleration, okay, of 3 over radical t plus 1 feet per second, or per second squared, at time t equals 0 seconds. The initial height of the rocket is 0 feet, just like this, okay. The initial velocity is 2 feet per second. This initial velocity is 5 feet per second of rocket A, okay. Which of the two rockets is traveling faster at time t equals 80? Uh-oh. So at t equals 80, we have rocket A going 49 feet per second. What the hell is going on with this rocket B? Okay. That's what we got to find out. No problemo. All right, so A of t, this is rocket B. A of t equals 3 divided by radical t plus 1. So we got to figure out what the velocity is at t equals 80. So first off, we know that PVA, if we have acceleration, we need to find the integral in order to get the velocity. So the integral of this thing is what I need. So this is going to be the velocity of rocket B. This will be the velocity of rocket B is this. Okie dokie. So keep it cranking. So we got this. So I'm going to write this as the integral of 3. I'm going to bring this up. So this is going to be t plus 1 to the negative 1/2 dt. That's going to help me make it easier to find this antiderivative right here. So this is like undoing the chain rule. And so the derivative of the inside is 1. This is 1t. So if you divide by 1, you just get the same thing. So I'm not going to do that. And then you add 1 here. So this is going to be 1/2. So, and then you divide by 1/2, which is, dividing by 1/2, which is times the reciprocal, which is 2 over 1. So dividing by 1/2 is multiplying by the reciprocal. So this is going to be 6. 3 times 2 is 6. And this is going to be 1/2, right? So that's 1/2. So it's going to be radical t plus 1 plus c. So we don't know what this is. So what the hell is the plus c? So this is v of t of rocket B. The plus c, why do we have that? Because what it tells us is that the initial velocity is 2 feet per second. So that's important information. We need to use that. So initial velocity is 2 feet per second. So that would mean that velocity at 2 seconds is 0. And so this is t. T is 2. So this is 0 equals, no, sorry, my bad. T is 0, velocity is 2. My bad. Messed that one up. So this is, sorry, 2. Velocity is 2 when time equals 0. My bad. Sorry about that. So this is going to be 2 equals 6 times radical 1, which is just 1, plus c. So 6 plus c, so subtract 6, what do you get for c? Yeah, -4. 6 minus 4 is 2. Makes sense. Okay, so what do we have? So velocity of rocket B at any time is 6 times radical t plus 1 minus 4. Okay, so now I want the velocity when time equals 80, because I want to compare that to rocket A, because that's what it asked me. Rocket A is 49, so hopefully, so see which one is greater. So which of the two rockets is traveling faster? So let's see if rocket B is going faster than 49. That's what we have to figure out. Okay, dokie. So I want, what is the velocity when time equals 80? So that's going to be, the velocity is going to be 6 times radical 81 is 9 minus 4. So this is 54 minus 4, which is 50, which is greater than 49. So rocket B is moving faster at t equals 80 because 50 is greater than 49. We all know that. Thank you very much. Bam. Nice. Okay, so that's all the different parts. We got it. Excellent job. If you need to redo this part, pause the video, see if you can do this whole thing again without any looking at the notes. If this was confusing to you, nice job. Text me if you have any questions. Great job, everybody.